Okay, so the notes for 12-7. Again, if you don't have it handy, you're going to need your calculator a lot in these last couple of sections in the course. So have them ready. So we're going to talk about three different things. The first thing we're going to talk about is common logs. When we talk about common logs, we're talking about a log with a base of 10. When you see the log button on your calculator right here, log, that is a log base 10. It's a common log. It's what all calculators are going to have. Because it's an understood thing that common logs are always base 10, we don't write the base in there. So if you just see the log of x, it means the log base 10 of x. And again, it's because our number system that we use in the United States is base 10. So that's why those are common logs. So your calculator has the log button and will do approximation of logs for you. However, to evaluate the common log of a power of 10, you don't need a calculator. So for example, if I wanted the log of anything, let's say I wanted the log of 3, I would just press the log button, pop a 3 in there, and it would approximate the answer for me. But if I'm doing working with powers of 10, I don't actually need the calculator, because if you think about it, this is the log base 10 of 10 to the first. Remember that property? If these two bases are the same, the answer is simply the exponent. So the answer is 1. This is really the log base 10 of 10 cubed, because 1,000 is what 10 cubed is. These two are the same. My answer is 3. What is this? This is really the log base 10 of 10 to the negative 1. 1/10 is 10 to the negative 1. Since these two bases are the same, my answer is simply negative 1. And if you wanted to check it, if I do the log of 1,000, you're going to see that the answer is 3. So trust me. Now, look at this one. It says solve for x, give the exact solution, and then approximate to the nearest 4 decimal places. So look, what is this base? Since there's nothing there, it's a base of 10, correct? Use your relationship, changing from a log statement to its related exponential. If I were to do that here, I would have 10 to the 1.2 power is equal to x. Or in other words, x is 10 to the 1.2 power. So this is the exact solution. To get the approximate solution, I'm just going to pop it into my calculator, and it says approximate it to the nearest 4 places. So I'm going to do 10 to the 1.2 power. And there it is. So if I go out to 4 places, 1, 2, 3, 4, what does the 3 do to the 9? It keeps it a 9. So it's going to be 15.8489. There's the approximate solution. So we just talked, there's 3 things in this section. Common logs is the first one. We're done. Natural logs is the next one. So there are 2 log buttons on your calculator. The log button right there we talked about is the common log. The other one is this ln. That is the natural log button. So if you quickly look, what's right above the log button? It's 10 to the x, because that's a common log. It's a base of 10. If you compare that to this one, this is natural log. Look what that is. That's e to the x. That means they are logs base e. Well, what in the world is base e? E is a number. E is a number like pi, okay? Pi is probably the most famous irrational number. Irrational, of course, means that it keeps going on and on forever with no repeating pattern. And you know, pi is arrived at by using circles and finding the diameter and the circumference and dividing. So it's a very popular number. E is another popular number. It's an irrational number. It's approximately, now this has been rounded because it actually goes on and on forever, but it's approximately 2.7183. So it is the natural log. So it is really a log with a base of e, but we don't write it like that. We write it as ln of x. That means natural log. So I showed you where the button is on your calculator. It's right there. That's a log base e. So let's look at our next example. Use the calculator to approximate the natural log of 8 to 4 places. So here we go. So I'm just going to press ln. So there's natural log of 8. There it is. If I go to 4 places, 1, 2, 3, 4. So this 4 keeps this 4 the same. So it's 2.0794. Is that what it was? 0794. So let me just quick show you something. So what we just figured out is that the natural log of 8 is 2.7094. Or 0794. That's what we got when we plugged it into the calculator. I want you to remember what that really means, because otherwise you're just going to be plugging numbers into the calculator. Remember, this is really a base of e. So that means that e, which is about 2.7, to this power is equal to 8. This to this power is equal to 8. Let's kind of check that. You don't have to write this in your notes, but I'm going to write e to the 2.0794 power is equal to 8. Let's check that into our calculator. So if I go and I plug in e to that power, so to get to the e, it's going to be second ln, there it is, to the 2.0794 power. Now, am I going to get exactly 8? No, I can't get exactly 8 because I rounded. But look what I get. That's pretty darn close to 8. So whenever you're finding these values, remember what you're really finding is an exponent. Whenever you're finding a log, you're finding an exponent. So you see E in a lot of formulas. And we're just going to do the banking one for right now. So remember how in our previous section we had that formula that found the amount of money in account or the amount of money owed monthly or quarterly. So it's compounded a certain number of times per year. Daily would be 365. So that was that formula that had the N in it. Okay. This is our formula that we're going to use. And what this does is it compounds the value if the interest is compounded continuously. So if it's always being compounded, not monthly, not quarterly, not daily, not hourly, but if it's constantly being compounded. So whenever you see the words compounded continuously, you should know that you are going to use this formula. And yes, you need to know this formula by heart. I will give you the other formula, the one with the N, the longer formula, but this one you need to know. It's that important. Think of it as PERT, P-E-R-T. So it's P-E, and E is that E that's on your calculator. That value that's about 2.718. R is your rate, again, is a decimal. And T is your time in years. So we want to find the amount owed at the end of 5 years. if $1,600 is loaned at a rate of 9% compounded continuously. So what is the value going to be if $1,600 times E, our rate is 9%, so that's 0.09 times our time is 5. So that would be A equals 1,600 E to the 0.45. So you can pop that into your calculator. So it would be 1,600. Oops. Oh, let's try that again. 1,600 E, so that's second ln. There's your E. And to the 0.45 power. So there you go. Now we're going to round it to the nearest cent. Well, what is this 9? Due to this 29 cents, it makes it a 30 cents. So $2,509.30. So you borrowed $1,600. 9% is quite a lot. At 9% after 5 years, you'd actually owe $2,509 and some change. That's a lot if it's compounded continuously. All right, so know that formula, highlight it, do anything you need to do. All right, our third thing that we talk about in this section is the change of base. So we just talked about in the calculator, when you see the LOG button, that means a base of 10. So the calculator doesn't have a button for bases unless it's base 10 or base E. So actually that's a lie. If you have certain programs in your calculators, you can change the base to base 5 or base 4, but you may not have that. So if you don't have that, which I do not, we need to have a formula. And what this formula does is it changes the base for you. It's very cool. So it's called the change of base formula. That's inventive. Okay, so here's what it says. If I want to find the log base B of A, it's simply, so this is going to change the base. The log of A, so it's in the common log, notice that's a common log of A, divided by the common log of B. It's true also for natural logs, but people rarely do that. I would just stick with the common logs. Just use the LOG button. It just makes sense. So look, here's what that means. If I want the log base 3 of 10, so it's a base of 3. The LOG button on your calculator is base 10, so we can't use that button. Here's what you do. You simply take the common log of 10, which is this number right here, the bigger one in size, and divide it by the common log of whatever your base is. It's that simple. So in my calculator, if I take the log of 10, remember it's common log, so it's just the LOG button, divided by the log of 3, that's going to give me the log base 3 of 10. So you can see that that's what, if I just round it off slightly, it's going to be about 2.096. I'm going to go there. There you go. So one last time, before we end this set of notes, I want to remind you of what you just found. You just discovered that the log base 3 of 10 is 2.096. That's what you just found out. So what you really found out is that if I take 3 to this power, using that relationship from the very beginning of logs, 3 to this power is going to be approximately 10. That's what you found. Whenever you find a log, you're really finding an exponent.